All right, so let's read this. It says, at time t, the position of a body moving along the s-axis is s is equal to t cubed minus 27t squared plus 240 t. Actually, I'm going to write that over. That looks a little sloppy. And so it says find the body's acceleration each time the velocity is equal to 0. So if this is the position equation, then the velocity is just the derivative of that, which is 3t squared minus 2 times 27 is 54t plus 240. And then the acceleration is the derivative of that, which is going to be 6t minus 54. So that's part 1. And it says find the acceleration when the velocity is equal to 0. So I've got to take this thing, set it equal to 0. $240. Well, the first thing I'm going to do is I'm going to factor out a 3. So if I factor out a 3, I get 3t squared minus 54 divided by 3 is, I think, 18. Yep. So this becomes 18t. And then this becomes 80, I think, right? Is that right? Yeah, let's just double check. 240 divided by 3 is 80. Okay, good. Now if I divide both sides by 3, I get 0 is equal to t squared minus 18t plus 80. So to find the zeros of this thing, I'm going to say t squared and then positive 80. And I need to figure out what numbers I could plug in here that when I add them up, they're going to give me negative 18. In other words, this plus this has to equal negative 18. Well, that's easy. That's just going to be negative 8 and negative 10, right? Because negative 8 times negative 10 gives me a positive 80. But then we get a negative 8t and a negative 10t. So 0 is equal to t minus 10 and t minus 8. Or my zeros occur at 8 and at 10. So what I need to do now, this is going to be my acceleration a, so I need to figure out what a of 8 is, which will be 6 times 8 minus 54, and a of 10, which would be 6 times 10 minus 54. So this would be 48 minus 54, and I think that's a negative 6. And over here, this would be 60 minus 54, which I think would be a positive 6. Yeah, I think that's right. And so we want to match this up. I think it's C.